In this lecture, we will discuss about the area of using double integration. So we calculate the area by using double integration. So for this, we have two curves that f1x and f2x be two curves. The ordinates of x are a and b. So we have this type of these are the ordinates we consider for x, and the curves we are using has f1x to f2x. So this ordinate we consider as x equal to a, to x is equal to b. So when we are going to obtain the area by using the double integration, so it is clear one limit will be the variable limit and second limit will be the constant limit. So these two curves are given. So we have to calculate the area between the curves. So we also calculate the value of one limit when only two curves are given. So we will discuss questions related to that also. So here the variable limit we take for y. We take the variable limit for y. That means we are using the elementary strip parallel to the y-axis. So you can write down as y equal to f1x to y equal to f2x. So the limits for x is x is equal to a, x is equal to b, and y. So y is equal to f1x to y equal to f2x. So when we take the elementary strip parallel to y-axis, the variable limit for the y. Variable limit for y, so when we are uh, doing integration, so first we integrate with respect to y. That means first we solve the variable limit, then we solve the constant limit. So when we obtain the area of this shaded region, so what is the area of this region? You can choose as the points A, B, C, D. So we are going to calculate the area of this A, B, C, D. So the area of A, B, C, D. So when we are going to calculate the area of this, so the area of this equal to, so you can write down the double integration. That means integrate the ordinate x equal to a to x equal to b, and y is equal to f1x to y equal to f2x into dx dy. So we remember this formula when we are going to evaluate the area. So area is equal to first ordinates. That means first ordinate we have taken as constant and second ordinate we have taken as the variable limits. So this is the formula for obtaining the area between two curves, maybe between one line and one curve. So we evaluate the area of the curves. So now we take the questions related to this so you can understand how to evaluate the area. So find the area, find the area of circle x square plus y square is equal to a square. Okay, so here we are going to calculate the area of a circle. The radius is a. Okay, so what is the formula for area of circle? So directly we know that pi r square. So pi r square is the area of the circle. So here we radius take as a, so the answer will be in the form of pi a square. So this is our answer. Because we know that the direct the formula of area. So when we calculate the area of a square circle, gives us pi r square. Area of a circle is pi r square. Okay, so a is the radius of the circle. Now we need to draw the circle. So we have this quadrant. So now we draw the circle with radius a. So this is our circle with radius a. So these are the axes. Here is the origin. So we see that when we draw a circle in this particular quadrant, so that means this makes a symmetry. This makes a symmetry. So that means this area is equal to this area is equal to this area and equal to this area. So while we are going to calculate the area of the circle. So area of the circle. So when we obtain the area of the first quadrant, so when we obtain the area of the first quadrant, so the coordinate of this is 0 comma a, and coordinate of this equal to 0, sorry, a comma 0 and 0 comma a. And when we take the elementary strip, parallel to y-axis, so here x-axis y equal to 0, and we have the circle x square plus y square is equal to a square. So what is the value of y? The value of y, so you can write on y square equal to a square minus x square, and y equal to plus minus root a square minus x square. But when we are taking only the positive quadrant, so the limit or value of y will consider as a square minus x. So this limit here we write down as y is equal to root a square minus x square. Okay, so here y-axis x equal to 0. So the limit of x equal to x equal to 0 to a, limit of y equal to 0 to. So area of the circle, you can write down the integral x is equal to 0 to a, y is equal to 0 to root a square minus x square into dx or dy. So this is the area of the quadrant, okay. So here we are going to calculate the area of the quadrant. So and we have a 4 quadrant in the circle. So directly we multiply by the 4. So we evaluate the area of the circle of first quadrant and multiply by 4, so we can get the area of the whole circle. So 4 into x is equal to 0 to a, and we solve for y. So integration of dy equal to y or 0 to root a square minus x square or into dx. So apply the limit. So this is equal to 4 integral 0 to a, or when we apply the upper limit gives us a square minus x square, and the lower limit gives us 0 into dx. So this equal to 4 into integral 0 to a root a square minus x square into dx. The root a square minus x square into dx. So when we evaluate this integral, so we have direct formula, root of a square minus x square. The formula is, so we use the formula x upon 2 root a square minus x square plus a square upon 2 sine inverse x upon a. So sine inverse x upon a, or we apply the limit. So this is the direct formula for integration. So here we apply the limit. So we write down 4 here also. So we apply the limits when we put x equal to a. So it gives us a equal to 2. 2 into a square minus a square plus a square upon 2 sine inverse a upon a, minus lower limit 0 minus a square upon 2 into sine inverse 0 upon a. So sine inverse 0 is 0. So this is also equal to 0. So 4 into first term is 0 plus a square upon 2 sine inverse 1. Sine inverse a upon a means 1. Sine inverse 1 is equal to pi by 2 minus 0 minus 0. So this gives us 4 into a square pi upon 4 So this gives us 4 to 4 cancelled, a square into 5. Or you can write down as pi into a square. So this is our area. So we have already write the answer that we directly. So we have the area of a circle is pi r square, means pi a square when a is the radius. So we get the answer pi a square. Okay. So we calculate for first quadrant and multiply by 4. So then we get the area of whole circle. Similarly, we do the second question. Second question basically belongs to the ellipse. So find the area of the ellipse. So find the area of ellipse. Ellipse is given as x square upon a square plus y square upon b square is equal to 1. So we know that what is the area of ellipse? Ellipse area of ellipse is pi ab. So area of ellipse is equal to pi ab. So pi ab will be the answer of this question also. So now we calculate the area. Okay. So just here curve is given. In previous question, the only curve is given, circle is given. So we obtain the limit first, then we calculate the area of the curve. Here in ellipse, the curve is given, equation of ellipse is given. So we calculate the area by obtaining the limit. So the ellipse, okay, so this is the equation of that ellipse. This is x square plus y square, x square upon a square plus y square upon b square equal to 1. Ellipse also make the symmetry. Understand? So ellipse also make the symmetry. So that means when we obtain the area of first quadrant, then we multiply by the whole circle. Here we are going to calculate the area of whole circle. Area of whole circle. So just we put the limit for first quadrant only and multiply by the 4, so we can get the whole. So we take elementary strip parallel to y-axis. So when you take elementary strip parallel to y-axis, and what is the coordinate of this axis is a comma 0. Coordinate is a comma 0, and the coordinate of this equal to 0 comma b. So 0 comma b. So now we are going to evaluate the area of this quadrant, and for whole ellipse we multiply by 4. So what are the limit of y? So when we solve here this one, so this gives us y square upon b square is equal to 1 minus x square upon a square. So you can write down y square is equal to b square into 1 minus x square upon a square. This can be written as b square into a square minus x square upon a square. Okay, so we are going to calculate for first quadrant. So we take as the value of y will be the b upon a root a square minus x square. But when we are taking for first quadrant, so we take the limit as y equal to b upon a into root a square minus x square. Okay. अगर we are taking elementary step for this one, when means complete. So then we take limit as minus b upon a2 plus b upon a. Okay. But we are not taking the elementary step uh, for complete. So just we take in the first quadrant only. So that's why we take the limit as. Okay. Now, what are the limits of y? So the limits of y, are that way first we calculate the limit of x. The limit of x. The limit of x are x equal to 0 to x equal to a. So here is the a, or now x equal to 0 at y-axis, or y is equal to 0. So this is x-axis, y equal to 0 to y equal to b upon a root a square minus x square. Now the area, so we calculate the area of ellipse. So area of ellipse is equal to 4 into area of the quadrant. So 4 into x equal to 0 to a, and y equal to b upon a root a square minus x square into dx dy. Okay, so we do the integration. So that means first we solve the variable limit x equal to 0 to a, and integration of dy is y. So limit is root a square minus x square into dx. So this gives us 4 into integral x equal to 0 to a. So we apply the upper limit root a square minus x square minus 0 into dx. So b upon a we take outside from the integral. We are solving the integral for x. So now the same integration as previous question. So we use the formula directly. So a square minus x square, the formula is x upon 2 root a square minus x square plus a square upon 2 sine inverse x upon a, and 0 to a. So we do 4b upon a and apply the limit a upon 2 root a square minus a square plus a square upon 2 sine inverse a upon a minus 0. Sine inverse 0 is 0. First term, this term will be also 0, and this gives us 4b upon a into a square upon 2, or sine inverse 1 is pi by 2. So pi by 2 means 2, 2, 2 is 4, to 4 cancelled, a to a cancelled, so this gives us pi ab. Gives us pi ab. So this is our answer. So pi ab be the area of the ellipse. Now we take the another question. So evaluate the area enclosed between the parabola y is equal to x square and a straight line y is equal to x. Okay, so here with two curves are given, y equal to x square or y equal to x. So we calculate the area which include between these two curves. Okay, so first you know how to trace the parabola y equal to x square. Okay, so when we draw the curve, so we take the x-axis origin and y-axis. So y equal to x line, you draw this y equal to x, and y square equal to 4x along x-axis we draw the parabola, but here x square equal to 4ay. So x square equal to 4ay means y along y-axis. So parabola along y-axis. So this is the parabola we take as x y equal to x square. Now we are going to calculate the area enclosed between these two curves, that y equal to x or y equal to x square. This is our shaded region. We are going to evaluate the area of this particular region. Now how to find the limit? So when we are going to find the limits of this point, that is, this is the intersection point. So what are the coordinate of this point? So when we touch, that we cross intersect the parabola, So that means when we put a y equal to x here. So you can write down as x is equal to x square. So x equal to x square, so x minus x square is equal to 0. So we write down as 1 minus x. 1 minus x equal to 0. So 1 gives us x equal to 0 or x equal to 1. So x equal to 1. So when cross the curve y equal to x, this coordinate will be 1 comma 1. So x equal to 1, y equal to 1. So because here x equal to 0, y equal to 0 here. So the coordinate of this particular point is x equal to 1 or y comma 1. So 1 comma 1 be the point of this, and y equal to x be the line. Now we take the elementary step. We take the elementary step. So when we take the elementary step parallel to y-axis, so parallel to y-axis. Now we are going to take the elementary step parallel to y-axis. So parallel to y-axis. So here this is the parabola. So this is the parabola. So parabola is y equal to x square to this is the line y equal to x. So limit. So the limits are x is equal to 0 to x equal to 1. Okay, so here x equal to 0 with the origin and x equal to 1 is this point. So for x equal to 0 to x equal to 1 and y is equal to strip are taken parallel to the y axis. So y equal to x square to y equal to x. So these are the limits. Now we calculate the area. So the required area which is equal to double integration dx into dy. So first we take the constant limit x equal to 0 to x equal to 1. Then we solve the variable limit y equal to x square to y equal to x dx into dy. So first we solve the variable limit. So x equal to 0 to 1 and variable limit is y. So integration of dy is y and take the limit of x square into x or dx. So this equal to integral x equal to 0 to 1 upper limit x minus lower limit x square into dx. So this equal to when we integrate this, so integration of x is x square upon 2 or integration of x square is x cube over 3 and 0 to 1. So upper limit 1 by 2 minus 1 by 3 or lower limit will be 0. So 1 by 2 minus 1 by 3 gives us 1 by 6. 1 by 2 minus 1 by 3 equal to 1 by 6. So area between two curves, that means that is parabola and straight line will be 1 by 6. Now we take other questions. Find the area between parabolas y square is equal to 4ax and x square is equal to 4ay. So while doing this type of questions, you know the coordinate geometry also, how to draw the curves. That means the y square equal to 4x parabola. That means along x-axis. So we draw the parabola along x-axis. So have also parabola also have the symmetry. Okay, so we draw the curve again. Okay, so this is y square equal to 4x or x square equal to 4ay means along y-axis. So x square equal to 4ay. So x square equal to 4ay. So this is the x square equal to 4ay. Okay, so this is y-axis, this is x-axis, origin, x-axis, origin, and y-axis. Now, here we are going to calculate the area between two parabolas. So for two parabolas, we draw the curve. So this is x-axis, origin, and y-axis. So y-axis. So first we draw this, and second we draw this parabola y square equal to 4x. Okay, y square equal to 4x. Just okay. So we make the picture to add it and clearly understanding. So just okay. So this is the parabola. That means y square equal to 4x. Or we are going to calculate the area between this. That means between these two parabolas. That means this is our required area. This is our required area. So we are going to calculate the area of this region. Okay. So now this is the intersection point and this is origin. So both the parabolas passing through from the origins. The coordinate of origin is 0, 0. Now, first parabola is given as y square equal to 4x. Second parabola is given as x square equal to 4ay. So when you take elementary strip parallel to, you take elementary strip parallel to y-axis. Okay, so this will not be convenient. So we can choose as elementary strip parallel to x-axis. So but that will be the convenient for integration. Okay, but other so we take the elementary strip parallel to x-axis. So we take the elementary strip parallel to x-axis. So here we take the elementary strip parallel to x-axis. This is our required area. So parallel to x-axis. So the coordinates that means the parabola. So this parabola is y square equal to 4x. So for parallel to x-axis means x limit will be the variable form. So this parabola is y square equal to 4x. So the y square equal to 4x, so x equal to y square upon 4a. X equal to y square upon 4a. And this parabola is x square equal to 4ay. So x square equal to 4ay means x equal to root 4ay. So this gives us 2 root ay. So 2 root ay. Now we obtained this intersection point. So for calculating the value of y, you can take parallel to x-axis or y strip element strip. There is no issue for that. Okay, because we solve many questions related parallel to y-axis, so we solve this question to parallel to x-axis. Now, so from this y is equal to x square upon 4a. So we put the value of y in equation 1. So this gives us x square upon 4a to the whole square is equal to 4ax. So this we can write down as x raised to the power 4 upon 4a to the square is equal to 4x. So this we can write down as x raised to the power 4 is equal to 4a raised to the power 3 into x. Okay, so this we can write down as x raised to the power 4 minus 4a raised to the power 3 into x is equal to 0. So x we can take as common. So this gives us x cube minus 4a raised to the power 3 is equal to 0. Okay, so do the factors. Factor is first factor that means x equal to 0, or second factor we can take as 4a raised to the power 3 is equal to 0. So this will be the formula of aq minus bq. aq minus bq to a minus b. So we do the first factor a minus b. A minus b and a square minus ab plus b square. So second factor will give the okay imaginary coordinate. So we do not use second factor. We do not use this factor. So when we put x is equal to 4a. So x is equal to 4a. So y is also equal to 4. So the coordinate of this point is equal to 4a comma 4a. So now we write the limits. So when we write the limit of y, so the limit of y. Okay, so x equal to 4a. When you put x equal to 4a, so this y square gives us 4a into 4a, 16a square. So y also gives us 4a. Okay, so you write down y square is equal to 4a into 4a. So y square is equal to 16a square. So y equal to also gives us plus minus 4a. So y equal to, we take out the positive part, and so that means 4a. So limit of y is equal to 0 to y is equal to 4a. And the limit of x is equal to y square upon 4a. X equal to y square upon 4a. So x equal to y square upon 4a, 2x is equal to 2 root ay. Okay, so the required area, so we write down the required area equal to double integration dx into dy. So double integration dx into dy. So first we take for y equal to 0 to 4a, and x is equal to y square upon 4a to 2 root ay into dx dy. So here variable limit for x. So first we integrate with respect to x. So we write down y equal to 0 to 4a. So integration of dx is x, and take the limit as 2 root ay to y square upon 4a into dy. So when we integrate this with respect to y, so first we putting the limits. So gives us 2 root ay minus y square upon 4a into dy. Now, so when we integrate this with respect to y, so first term you see that 2 is already outside. This is constant. Root to a we can also take outside, and we write down this as 0 to 4a or root y dy. Root y dy minus 1 upon 4a, and we write down separate 0 to 4a y square into dy. Okay, so now this gives us 2 root a. What is the integration of root y? Means y raised to the power 1 by 2. So this gives us y raised to the power 3 by 2 upon 1 by 2 plus 1, 3 by 2. So 0 to 4a minus 1 upon 4a. Integration of y square gives us y cube upon 3. Y cube upon 3, 0 to 4a. So this equal to 3 by 2 means 2 by 3. So 2 2 is 4. 4 upon 3 into root a. 4 upon 3 into root a. Now put the value of y. So this is 4a. 4a raised to the power 3 by 2, or lower limit is 0. And minus 1 upon 4a. 4a raised to the power 3 upon 3, or minus lower limit is 0. So this equal to 4 upon 3 into root a, and 4 raised to the power 3 by 2. 4 raised to the power 4 into 2, 8. 4 to the 8. So 8 into a raised to the power 3 by 2 minus 1 upon 4a. So 1 upon 4a, so 1 4a will be cancelled. So 4a square, मतलब 4a का whole square, 4 is whole square is 4 4 जा 16. 16 into a square upon 3. So 16 into a square upon 3. So this term will be 8 4 the 32. 32 upon 3 or a raised to the power 3 by 2 into root a means a square minus 16 upon 3 into a square. So gives us 16 upon 3 into a square. So this is our answer. So hope you understand. So more problem we will discuss in next lecture.